This lesson has been developed in the framework of SCILED project. Module 1, Footwear Performance and Comfort. Unit 2, Mechanical Comfort and Footwear Performance.
Lecture 2.7. Softness, Flexibility and Lightweight.
This lecture addresses the softness, flexibility and lightweight of footwear. The next section presents the important definitions, concepts, theory and testing methods to measure softness, flexibility and lightweight. Then, the role of footwear and components is presented and explained as well as the comfort requirements. In the end, several innovative solutions to support softness, flexibility and lightweight are shown.
Definitions. Concepts and theory.
Softness is the quality of giving little resistance to pressure and being easy to mold, cut, compress or fold. Also, according to Cambridge Dictionary, softness represents the quality of being soft and not hard or firm. The antonym for softness is hardness, which is the property of being rigid and resistant to pressure. In other words, softness is the quality of giving little resistance to pressure, easy to mold, cut, compress or fold. To measure the softness/hardness of a material, it is necessary to use a durometer. Higher numbers indicate harder materials while lower numbers indicate softer materials. Durometer is typically used as a measure of hardness in polymers, elastomers, and rubbers, materials that are commonly used for manufacturing footwear bottom components like soles, midsoles and insoles. For testing shoe rubber and plastic, a Shore scale durometer should be used, while an ASCII scale durometer tester is used to test the hardness of any foam components for footwear. The common hardness scales are Shore A, normal rubber; Shore D, hard rubber and plastics; ASCII C, soft rubber; ASCII F, urethane foam, sponge and polystyrene foam. The special hardness scales are ASCII J, normal rubber and softer plastics; ASCII B, semi-rigid rubber and plastics; ASCII C2, soft rubber and sponge; ASCII CS, polystyrene foam; ASCII E, soft and cellular rubber.
For leather softness in particular, it may be measured following the standard ISO 17235 leather, physical and mechanical tests, determination of softness, which specifies a non-destructive method for determining the softness of leather. In this case, softness is the distension of the leather produced when a cylindrical rod of defined mass is lowered at a specified rate onto a securely clamped area of leather. This method is applicable to all non-rigid leathers, for example, shoe upper leather, upholstery leather, leather goods leather and apparel leather. This test should be used only as quality control or to create comparative tests to select the softest and lightest materials to be used in the footwear manufacturing. There are not recommended values available for upper materials softness.
This figure presents the comparison between the different Shore scales. For extra soft materials, the Shore 00 scale should be used. For example, a soft insock would have a hardness Shore 00 of about 30. Flexibility is the ability to bend or compress easily without breaking. The antonyms of flexibility are stiffness and rigidity. The more flexible an object is, the less stiff or rigid it is. This said, the rigidity of an object is the extent to which it resists deformation in response to an applied force. Flexible materials are characterized by the modulus of elasticity, where highly flexible materials have low modulus of elasticity. The torsional movement of the foot is inhibited by the footwear when compared to being barefoot. In barefoot conditions, the foot adapts more easily to any perturbation by allowing the rear foot to twist, preventing some injuries in the ligaments, when compared to wearing shoes. So, to promote footwear comfort, it is necessary to find a compromise between the protection against impact forces and the loss of torsional movement. Flexibility scores are calculated from the amount of effort required to bend the shoe. To measure the flexibility of a shoe, a flex tester simulates the range and rate of motion produced by a runner, and sensors measure the angle of flex and resistance produced by the shoe. Flexibility of a shoe product can also be evaluated by testing the longitudinal and torsional stiffness. For example, both dynamic longitudinal and torsional stiffness of footwear can be quantified by the use of Sauter's STM507 dynamic footwear stiffness test machine, which measures the force required to flex a shoe and the angle to which that shoe can be flexed comfortably. The result of the test is a stiffness index, which can be related to wearer performance and wearer expectations. A low stiffness index indicates a high level of footwear flexibility. The longitudinal stiffness test measures the force required to flex the footwear to an angle representing a 50 degrees flex of the foot or the maximum angle that can be achieved without exceeding a critical bending point. In the case of the torsional test, the shoe is twisted along its length to a fixed angle of twist. The torsional stiffness is recorded as the measured moment required to twist the test shoe. Summarizing, flexibility is the amount of effort required to bend a shoe. A flexibility tester simulates the range and rate of motion, and sensors measure the angle of flex and resistance produced by a shoe, and stiffness index can be correlated to wear performance and wearer expectations. A low stiffness index indicates a high level of footwear flexibility. Lightweight material is characterized by its low density. A so-called lightweight product is made of materials with low density without compromising the technical specifications. A light shoe may be produced by using materials with intrinsic low density or with a low-density 3D structure. Usually low-density 3D structure is achieved by incorporating air into the structure, increasing the porosity. In general, a light shoe is associated with higher levels of comfort. Nowadays, there is a growing interest in lighter materials by manufacturers, so that they can produce lighter products, responding to the demands of the market. These developments, which first appeared in sports footwear, are spreading to other types of footwear. The footwear lightness is one of the factors that influence the decision to buy. One method determines the mass and height of the shoe, and a rate is calculated to define the level of lightness. There aren't available ISO recommended values for upper materials or footwear lightness. Real density is determined by calculating the mass of a material by the volume, excluding the voids. Apparent density is determined by calculation the mass of a material by its volume including the voids. Both the real and apparent densities are important material properties related to a lightweight product. The real density is related with the intrinsic property of the material A, whereas the specific density is related with the density of the 3D structure made of the material A. There are no standard methods to determine lightweight of footwear. However, there is a method which determines the mass and height of the shoe, and a rate is calculated to define the level of lightness. There are no available ISO recommended values for upper materials or footwear lightness.
Role of footwear on softness, flexibility and lightweight.
To get a soft, flexible and lightweight shoe, it is fundamental to act in the design of footwear, selection of materials and also selection of components. For that, several factors shall be taken into consideration. Upper and lining materials shall be flexible, light and soft, as for example leather and bio-based textiles.
Sole and insole shall be flexible, light and designed with appropriate geometries so it does not restrict the natural movement of the feet. Polyurethane is a good example of materials used in soles.
Insole shall be designed to support the feet without any constraints and shall be flexible, soft and light. Another important factor to consider is the minimization of the number of components used.
Comfort requirements addressing softness, flexibility and lightweight.
Previously it was referred that flexion resistance is the number of flexes that the footwear is subjected to until there is a cut growth and/or initiation of cracks or otherwise fail at flex increases. The use non-flexible materials requires a design in a such way that do not compromise the comfort of the footwear. The evaluation of the resistance to flexion of upper and lining materials and products is made by visual analysis, where for leather uppers under dry conditions after 80,000 cycles and wet conditions after 20,000 cycles, there is no visible damage, and for coated leather, there is no visible damage after 20,000 cycles at -5 degrees Celsius. For lining under dry conditions after 15,000 cycles, there is no visible damage. And for other materials under dry conditions after 80,000 cycles and after 20,000 cycles at -5 degrees Celsius without visible damage. The recommended value for flexion of bottom materials and products is that the cut growth should be inferior or equal to 5,0 mm, and without spontaneous crack. Longitudinal stiffness is measured on whole footwear. A product is considered extremely flexible if its stiffness is very low, less than 2 Nm. If the stiffness is between 2 and 3.9 Nm, the product is very flexible. Medium flexible if stiffness is between 4 and 8 Nm. It is considered stiff if it is between 8 and 10 Nm, and very stiff if greater than 10 Nm. The recommended values for torsional stiffness are as follows: classed as flexible if stiffness is less than 1 Nm, Medium flexible if stiffness is between 1 and 2.5 Nm and stiff if stiffness is greater than 2.5 Nm. There are not ISO/DR guidelines available for softness and lightness.
Innovative solutions to support softness, flexibility and lightweight.
Walking barefoot represents the natural movement of the foot. In this case there is no interface between the foot and the ground. The direct contact between the foot and the ground helps the coordination of the muscles and body balance. Despite the fact that barefoot walking and running is becoming a trend nowadays, it is not something that can be done all the time. In this case, it is important to use soft and flexible shoes. Walking is a natural rolling motion from heel to toe. Using soft, flat and flexible sneakers or walking shoes designed to mimic the biomechanics of walking barefoot change how wearers walk. If the shoes are not flexible enough, foot joints and muscles are restricted by the shoes, causing feet pain, physical discomfort and possible injuries. When buying footwear, it is important to take in consideration that walking and running are not the same process. Walking shoes and running shoes are both built to provide comfort, but they are not the same product. They do not have the same design structure and functionality. Barefoot running shoes are an example of footwear that mimics the barefoot walking or running. They offer the closest feel to running truly barefoot. Soles provide the bare minimum and protection from potential hazards on the ground. Many have no cushion in the heel pad and a very thin layer, as little as 3 to 4 mm, of shoe between your skin and the ground. Most significantly, all feature a zero drop from heel to toe. Drop is the difference between the height of the heel and the height of the toe. This encourages a midfoot or forefoot strike. Traditional running shoes, by contrast, feature a 10 to 12 mm drop from the heel to the toe. Depending on the shoe functionality, walking, jogging, long-distance running etc., and also, depending on the way we strike the ground during these activities, there are different solutions available. Recent years' innovations regarding shoe softness and flexibility usually refer to the bottom part of the shoe. Bottom components are developed according to shoe functionality, for example for walking, jogging, long-distance running etc., the way we strike the ground during various activities. As referred before, the bottom part of the footwear has the greatest influence on flexibility, with great benefits regarding the perceived comfort during walking and running.
Softer materials will improve softness and flexibility while firmer materials will improve motion control. For example, duo-density soles often have softer materials on lateral side to temper impact forces and decrease the velocity of pronation, and firmer material on the medial side to counter excessive pronation. Factors like heel height, the size of the sole contact area, sole thickness and sole flexibility all contribute to gait stability. According to Wendy Terrell, if the foot has normal ranges of movement and no pathologies, flexible soles are recommended for general everyday activities. Also, for a blend of flexibility and stability, there are soles that have varying flexibility from heel to the toe area. A firmer material is used at the rear of the foot, while using a more flexible material in the forefoot allows a natural degree of flexion at the metatarsus phalangeal joints.
Safety shoes can also feature softness, flexibility and lightweight. The model presented here is built with EVA footbed that offers high rebound cushioning for all-day comfort and aluminum safety toe. FOOTWEAR is a Portuguese brand that produces safety footwear and accessories. Their products feature materials and design that promotes softness, lightness and flexibility. Soles made of EVA and/or using air tubeless technology ensures optimal performance and extreme comfort. Their insole is made of soft polyurethane and has a distinct shape which helps to stabilize the foot, while the deep, structured heel cup and full-length foam provide support and comfort.
3D printed shoes. Taking in consideration the fact that many specialists claim that the evolution and revolution of 3D printing will be comparable with that of mobile phones, we have to take a look at recent developments in footwear 3D printing. 3D printing technologies will allow great degree of personalization and customization of footwear and footwear components design and functionality, including softness and flexibility. Architect from Under Armour. It is designed with a custom functional 3D printed midsole from a combination of polymers and elastomers. Having a printed midsole, the shoe provides light and springy cushioning, along with the upper which provides stability. Adidas Futurecraft. It features a mix of mesh and prime knit over a 3D printed sole and midsole made from recycled polyester and gel knits.
Treadflex proposes for their shoes an integrated comfort system. The bottom components ensure great flexibility in the ball area and additional foam layers for softness and comfort. The upper part of Flex shoes is stitched directly to the sole inside out, stitch, and then turned right side out, turn. The stitch and turn system is characterized by softness and flexibility, and it represents the main feature of the Flex shoes. The Flex patented sole design maximizes flexibility, minimizes weight, absorbs shocks, all in order to relieve stress and pressure. The main feature of GoFlex shoes is represented by the articulated segmented sole design that provides anatomically correct ultra-flexibility. Also, the shoes incorporate the softness of a yoga mat with their cushioned Goga mat insole and memory form fit. Cotton Traders has a collection of sports and casual/classic footwear that is lightweight, features a flexible sole and also an arched full memory foam insole for instant comfort.